Have you ever wondered how a giant submarine can sink deep into the ocean and then rise back to the surface whenever it wants? It doesn't have wings, and it's much heavier than water. So what's the secret? Today on Simply Wonder, let's dive beneath the waves and discover how submarines float, dive, and travel underwater.
Simply Wonder.
Imagine you are standing by the ocean, watching a gigantic metal vessel glide across the waves. It is packed with heavy engines, enormous machines, and a large crew. So how does something this incredibly heavy stay resting right on top of the water? If you toss a small stone into the ocean, it drops straight to the bottom. Yet this massive, heavy metal tube stays right where it is. To understand why, we can look at a simple experiment you can try at home. Take an empty plastic bottle, twist the cap tightly, and push it into a bowl of water. It bobs right back up to the surface. But if you take that exact same bottle and fill it entirely with water and drop it back into the bowl, it sinks heavily to the bottom. The bottle's outer plastic shell never changed. This shows us whether an object floats or sinks isn't dictated by its tough outer layer. It depends entirely on what is stored inside. Looking at this diagram of our empty bottle, we can see why it floats. Inside, it's holding air. Air is extremely light. Because the bottle is mostly filled with this light air, the surrounding water is actually strong enough to push upward against it. Science has a specific name for this invisible upward push from the water. We call it buoyancy. When you fill the bottle with water, it becomes packed with heavy liquid instead of light air. Now the weight pulling it down is much stronger than that upward push of buoyancy, and the bottle is dragged to the bottom. Engineers use this exact rule to conquer the ocean. They designed submarines to magically change their internal weight, giving them total control over whether they ride the waves or dive deep below them. Inside the submarine's hull are empty spaces called ballast tanks. Kept full of air, they make the ship light enough to float. To dive, bottom doors open, letting heavy seawater rush in and push the air out. By balancing this water, the submarine hovers underwater. By swapping air for water or water for air, the submarine has the power to choose exactly where it wants to be in the ocean. Once submerged, the submarine must move through millions of gallons of heavy water. It does this by spinning a massive propeller, pushing the ship forward. To steer up or down as it travels, it uses small wing-like fins on its sides. By tilting these fins, the submarine glides smoothly through the water, almost like an airplane flying. But driving underwater presents a huge problem. It is completely pitch black down there, and because the deep ocean presses in with crushing force, building large glass windows would be incredibly dangerous. To navigate without windows, the crew uses sonar. The ship sends loud pulses of sound into the dark water. When these sound waves hit an object like a rock, they bounce back as an echo, letting the crew map their surroundings. To survive in the deep sea, humans built machines that behave remarkably like ocean animals, using fins to swim and echoes to see in the dark. Eventually, every mission ends, and the submarine needs to return home. But right now, it is deep underwater, and its hidden ballast tanks are totally flooded with immensely heavy seawater. To get back up, the ship relies on a brilliant mechanical trick: compressed air. This is regular air that has been squeezed incredibly tightly and stored in super strong metal tubes inside the ship. When the captain gives the word, the crew releases this stored air directly into the flooded tanks. It erupts outward with enormous power. Because the air was squeezed so tightly, it aggressively expands, physically shoving all that heavy seawater out through the bottom doors. In seconds, the tanks are filled with bright, light air once again. Without that heavy water holding it down, the ship instantly reclaims its buoyancy. Suddenly, the immense weight of the ocean around it becomes a helpful force, lifting the entire massive vessel straight upward. Propelled by the water pushing from below, the submarine breaks through the surface with a massive splash, returning safely to the open air and sunlight. Engineers have spent decades perfecting this delicate balance of weight and water to build these incredible vessels. But the core rule driving them all remains beautifully simple. Air inside the tanks helps the ship float up, while water inside the tanks helps it dive down. A submarine is a masterclass in the careful balance of air, water, and weight. If you enjoyed discovering the science behind this metal giant, hit that subscribe button.
Simply wonder.